Hello everyone. In this video we're going to be discussing the graph end behavior and specifically how to write its notation properly. Because sometimes we just say x is going towards the left, the function's going up or down, but that's not how it's going to be written on a lot of tests or EOCs or whatever test you take in the future, because they have a certain notation for that sort of stuff. So I'm just going to show you that notation. It's not really any mathematical sense, it's just a way of writing directions. If you guys know how north, south, east, and west goes, it's kind of like that, but for math graphs, right? But let's take a look at a graph first, or just, I guess, the coordinate plane. We, of course, know our x-axis and our y-axis, but I'm going to call the y-axis the f of x-axis because we are specifically referring to functions here. I think in this PowerPoint it's going to call them p of x. It doesn't really matter what it's called, it just gives it a different name, but it still means the same thing, it's still a function. Okay? So let's just talk about directions. So typically when we say we go left, we say we go left, right? And as we go left, we get to smaller and smaller numbers, right? -5, -10, -15, etc. But if you go all the way down, right, you're never actually going to get there, but if you just keep going to the left, that means you're approaching negative infinity, right? You go all the way, so you can't really go anymore. You're going to get closer and closer towards negative infinity. And of course, the same is true if you're going the opposite direction, right? If you're going to the right, is kind of how we've said it, right? But notation-wise, if we're going to the right, that means we're approaching positive infinity on our x-axis, okay? Of course, again, the same thing could be true for f of x scale, your y-axis. As you move down, -5, -10, as you move down towards smaller and smaller numbers, you're going to get closer and closer towards negative infinity on that axis. And of course, same thing if you move up, right? If you go upwards, you're getting higher and higher and higher to bigger numbers, you're going to be approaching positive infinity for that scale. So just remember that as you move to the left, it's going towards negative infinity. As you move to the right, it's towards positive. As you move down, it's towards negative infinity. And as you move up, it's towards positive infinity. Okay, so we're going to be using that as the main thing that we're going to discuss in this video, sort of the notation and how to specifically write left, up, down, and right. Okay, we've seen these graphs before. We're not going to be, we'll look at these graphs, but we're not going to be focused on their degree. Well, we are a little bit, but we're not going to pay attention to like the roots or anything of that nature. We're just going to be looking at the end behaviors and specifically how to write the direction that they're going. Okay. So here's a nice little chart that sort of outlines how end behaviors work on different types of graphs. It's very well put together. The only thing that I would really change about it is instead of saying a greater than 0, I would just simply go with positive, right? We've mentioned that before, a positive function. And of course, a is less than 0, then it's negative. So I would make those changes just so it's a little bit more clear for us. But we've dealt with these. We've established these before in the previous video. What makes an odd function odd, an even function even, or a positive function or a negative function. All right. So if we come across a positive function that's odd, something like this here, this is the notation we're going to be using. Okay. But let's talk about kind of what that means. So if we have a function that's odd, right, something kind of like what you see in that one on the top left. What that notation is saying is as you approach, let's use a different color, as you move to the left, right, that means as x approaches negative infinity, right? As you're moving towards the left, that's your x-axis, and it's going towards negative infinity. As you're doing that, the function is going down. That means that p of x, I guess is what it's calling it here, p of x is approaching negative infinity, right? Because if our function is going down, it's going towards negative infinity. So that's why we're saying p of x is going towards negative infinity. But we also have more to say, right? By the way, that's what this is saying right there. There's more to it than that, right? We wanted to talk about if it's going towards the right, which means if it's moving towards the right, that's when x is approaching positive infinity. Our function is going up. So as we move towards the right, the function's going upwards. So we would say as x is going to the right, or as x approaches positive infinity, our function p of x is also approaching positive infinity. Okay, so in a sense, rather than saying left, we're going to be saying x approaches negative infinity. And instead of saying right, we're going to be saying x or approaches positive infinity. All right, so every time you say the word left, you're going to be replacing it essentially with this. And right, you'd be replacing it with that. So if you want to think of it as more just like a translation for now, that's fine. At some point, after doing enough of these, it should be as relatable or as common sense as north, south, east, and west. I know you guys are good at those directions. This is the same thing, but just for a mathematical grid. All right, if you want to say up, you'll be saying that f of x, or whatever the name of the function is, up would be the y-axis, or the fx axis, is going towards positive infinity. And if you want to say down, you'd be saying your function is going towards negative infinity. So these are just kind of a translation, if you will. Again, we're used to saying these words. The function goes left, right, or up, or down. But on a test or something that you see, would have, they'll be saying stuff like this. And I want to just make sure you understand what they're referring to. What do they mean when they they say x approaches negative infinity? Like, what is that all about? So I want to just make that clear today. Okay, we're not doing really any mathematical problems. We're just going to be talking about the directions and sort of translating the notation properly so that you can have a better understanding of how it works. So let's jump into a couple examples. There are 4 of these, but I'm just going to do these first 2. All right, so we have the function q of x. All we need to identify is the leading coefficient. That's just to tell us whether it's positive or negative. The degree, just to tell us if it's even or odd. And once we know if it's positive, negative, or even or odd, then we can establish which directions the end behaviors go. So for q of x, all we're really looking at, by the way, in all these is the first term. None of the stuff here really matters in terms of what the direction of the graph is going to do. So I have a negative coefficient, so I know this is a negative graph, and I have an even power, so I know it's an even function, right? So I know it's even, and I know it's negative. So if I want to make a quick sketch, I know nothing about the shape of this graph, other than I know it's even, which means it's both ends are going the same direction, and it's negative, meaning both are going down, right? And if you want to look back at that chart that we just had, an even negative function would be something like this down here, okay? And so there's a notation. You could simply copy this down if you wanted to, but we're going to quickly kind of explain it so you get an understanding of how it's all working. So we know just based on essentially this term that it's negative and even, and now we're going to translate how its end behavior works. Can I get this to work? Yes. Okay. So let's start with the left side. As we approach the left, which means our x-axis is going towards negative infinity. So as x is going towards a negative infinity, again, that's just saying as we move to the left, the function, which I guess is called q of x here, right? So let's establish that. Q of x is going towards negative infinity, right? Because it is going down. So as we're moving to the left, as the function goes further and further to the left, it's also going further and further down. So that would mean as x approaches negative infinity to the left, q of x approaches negative infinity down. But also we want to establish the other side, the other end behavior. So as x approaches positive infinity, which just means as it's moving to the right, the function itself is going down, meaning q of x is going towards negative infinity. So you'll see that these are exactly what you would see on your chart, right? As x approaches negative infinity, q of x approaches negative infinity. And what was the other one? As x approaches positive infinity, q of x approaches negative infinity. Oops, wrong way. As x approaches positive infinity, q of x, or they call the p of x there, goes towards negative infinity. So it's the same thing. Like I said, you could have copied them down as long as you knew that it was this type of function you were looking at, an even and negative function. But I want to kind of explain sort of how to read the directions, because that's, I think, the more important thing. Let's do one more just like this. B. So for B, we're just looking at whether it's even or odd or positive or negative. So let's look at the coefficient. It's a positive number. So I know this is a positive function. And it's an odd exponent, so it's an odd function. So it's positive and odd, meaning if you go back to your chart, it's going to look, let's kind of erase what we have here. It's looking kind of messy. Positive and odd means it's going to look like this function, right? That's an odd function and it's positive here. So you could, again, at least for the beginning stages, kind of copy this down, but I don't really want you to. I want you to kind of know how it's explained. So, but we know it looks like that. We know it looks something like this. So that means, if we're reading this correctly, that as we approach the left, so again, that's saying as x goes towards negative infinity, our function, which is called p of x here, our function is going down, right? As you're moving to the left, our function is going downwards. So we're going to say our function is going towards negative infinity. And then the opposite direction, as x approaches positive infinity, right? As x moves to the right, as it gets closer to positive infinity, then our function p of x, as you can see, is going upwards. So p of x is approaching positive infinity. All right, and of course, as I said, if you go back to that chart, you'll see that that's an exact match for its conditions. Okay, so it's just like translating, is all it really is. It's not mathematical processes, it's just translating, understanding the notation and how it's written. So there's these two problems that we would have done in class, but I'm going to just skip them for this video because it's really repetitive. They're the first two. If you want to pause it and try it yourself, you can. I'll show you the answers and you can see if you're right. Okay, but I'm going to move on to the graphs. Now, so this, in a sense, should be a little bit easier since the graphs are already there, right? Identify whether the function graphed has an odd or even degree, a positive or negative, and let's just write its end behaviors. So this graph, it's odd. We know that because one side's going up, the other side's going down. And it's also negative because it's the left side that's going up and the right side that's going down. So if we know it's odd and it's negative, that helps us if we want to go back to that table and sort of translate how the notation works, but we can still read it by looking at it here. So let's talk about it going to the left side first. So as x gets towards negative infinity, which means as we're moving to the left, as we're going towards negative infinity on the x-axis, the function, as we can see, is going upwards. So our function, which we'll just call f of x here, our function is going up, meaning it's approaching positive infinity. So let's look at the left side, the right side. As x moves to the right, which means as x is getting closer to positive infinity, so it's moving towards positive infinity, our function is going down. So our function f of x, as if it's going down, is going towards negative infinity. All right, and that's it. That's it. And again, if you go back to that table, you'll see that matches it perfectly. As x goes to negative, f of x goes to positive. As x goes to positive, f of x goes to negative. All right, let's just do one more just for good practice. Again, there are two more. I'll probably show you those, but I won't talk about them just because it's repetitive. But I think we got the point across in the video. I don't want to be too long. All right, but let's establish whether this function is even or odd or positive or negative. So it's even, as we can see, because both ends are going the same direction. And it's positive because both ends are going in an upward direction. Okay, so we know it's even, we know it's positive. So that helps us out if we're going back to that table to kind of help us out. But we don't even need it because if we look at the graph, right, let's talk about it going to the left. So as x goes towards negative infinity, as we move to the left, the function is going upwards, meaning that this function, we'll call it f of x again, if it's going upwards, it's going towards positive infinity. And of course the right side, so as x approaches positive infinity, as we move to the right, as we get closer and closer towards positive infinity on the x-axis, the f of x axis, or the y-axis, our function is going up, meaning it's going to be going towards positive infinity. All right, so I'll quickly go ahead and just kind of fast forward a couple graphs, and if you guys want to pause it, try to answer it real quick. I'll quickly show you the answers. But other than that, I think I'll end the video here so it's not too terribly long. And I will see you guys in the next one. All right, bye-bye.